Okay, so today I'm going to talk about the momentum balance. So for this one, this is a cube, actually in 3D. There's a z-axis in and out of the page. But I only draw it in the 2D. So the length of this side is delta x, and for this one is delta y. So on the left side, I have sigma xx. So on the right side, I have sigma xx plus delta sigma xx. And same for this one, I have sigma yy, but on this side, I have sigma yy plus delta sigma yy. And also for the shear stress, this one becomes sigma yx plus delta sigma yx. Okay, so we can apply the Newton's second law here, which is sum of fx equal to m of ax. And for this one, we only focus on the phase that is norm of the x-axis. So I have max here, and m can be wrote as rho v, so I can write it as rho delta x delta y delta z dot times the x squared over dt squared. So this one is actually the acceleration, because acceleration is second derivative of the displacement with respect to t. Okay, so now we write the sigma xx dot sigma dot delta y times delta z. Delta y is times delta z is actually the phase of this side. So sigma xx times delta y delta z is actually the force along this side. And same is for this side. The area is also delta y times delta z. And we set the right side as positive and left side as negative, and bottoms as negative. So we also have the sigma zx here, which is out of the page, and the sigma zx plus delta sigma zx, which is inside of the page. Now also we plus the body force. Body force here is actually this delta x, delta y, delta z as the volume of it, and equal it to the Newton's second law, which is max, which is this term we have here. And we cancel the sigma xx, sigma xx, sigma xx, sigma yx, sigma yx, sigma zx, sigma zx, and left with delta terms, and divided both sides by delta x, delta y, delta z. So we have sigma xx over delta x plus delta sigma yx over delta y plus delta sigma zx over delta z, and also plus the bx, which is the body force along the x-axis, which is equal to rho times the a acceleration here. And we're taking the delta x, delta y, and delta z goes to zeros, because we assume they are very small. So we finally obtain this one. This is actually the equation for the momentum balance. So we can write it as the general form as delta sigma xj over delta xj plus bx is equal to rho du of x squared over dt squared. And this is the momentum balance equation for the stress along the y-axis, and this is for the stress along the z-axis. So if there's no acceleration, we don't have the max here, so the right side is going to be 0. So we only have the stress in all 3 directions plus the body force in that direction, which is equal to 0 here.